That's good.
I probably have it online, but it is, but currently.
Okay. So we are still talking about organic chemistry. We're talking about carbon chains. So I have two handouts. I have the note sheet, and then I thought that the power would go out on the last day before school. So I figured out the slides. So this first topic, I think everyone did already in chapter 11. I'm not sure why it got linked to chapter 11, but it is a chapter 12 test question, naming normal alkanes. So we'll go over that today. I think you already have covered that. So an alkane, that's what we're talking about in this chapter. An alkane is a hydrocarbon with only single bonds. So in chapter 13, we'll talk about double and triple bonds. Right now, we're only looking at single bonds and naming those. So what we do to name those is we count up the number of carbons in the chain, and then name it based on the number of carbons. So again, you've already all done this topic, but there's a table here. You count up the number of carbons, and that's the name that goes with it. So on the test for this chapter, I have seen 11 carbons and 12 carbons, so that's kind of weird. So just don't forget those kind of weird ones at the end. So undecane is 11, dodecane is 12. So watch out for those ones. Okay, we have this table. All right, so we are going to have to practice. So this is how chemicals are named. We figure out which carbon chain is the longest. It could be along the side chain. We just have to find the pathway that is the longest. And then we're going to use this list to figure out. So however long the longest carbon is, that's going to be the parent chain. And then we name it based on the name in this table. Okay. So let's practice. On the left, if we had to name the parent chain, what would the longest carbon chain be on the left?
6.
Okay, and so it would be 6, it would be hexane. Good. So it would go through the side chain. So 1, 2, 3, 4, 5, 6. We would have 6 carbons. So it's not always the middle chain. It can be the side chain. So just find the longest chain. How about this one? What would we call the parent for this molecule? Good, butane. Good. So you are either going to have to memorize these, or you're going to have to write them on your note card. So once we have figured out the longest carbon chain, we need to figure out the correct way to number. So we need to number based on, we want to minimize the first group. So that's our first rule. Minimize the first group. If we have a tie, we're going to minimize the most side chains. So that's called, anything that's like a branch off the side, that's called a side chain or a branch. Okay, so first we're going to figure out the longest chain. And then we could either number from the left to the right, 1, 2, 3, 4, 5, 6, Or we can number from the other side, 1, 2, 3, 4, 5, 6. Because if we number this way, 1, 2, that puts the side chain at a smaller number. We will go with the smaller number side chain. Does that make sense? So we want to minimize the first carbon chain, or the first branch. Okay. So here's another example. So this is a tie. If we go from left to right, we can go 1, 2, 3. If we go right to left, we would have 1, 2. So the first one's tied, but we can get the second chain to be a smaller number. You see that? So this would be correct because we can get this carbon chain to be a 2 and this one to be a 3. If we went the other way, it would be 1, 2. That's the first one's minimized. 3, 4, 5. This one would be at 5 instead of 3. So we want to minimize the first one. That's our first goal. And then if there's a tie, we want to minimize any of the second branches. Questions on that? Does that kind of make sense? Okay. This is something that it's not too bad, but you do have to practice it. You have to go through your head. Okay, so try these ones. So on the left, what would we number that methyl group on the left? What would its number be? Lost my pen. Okay, did you decide on a number? Maybe 6? Okay, so let's try. Oh, where's the pen? Is the pen going to turn on today? Maybe I can just try it on. Okay, 1, 2, 3, 4, 5, 6, 7. So what would the parent chain be here? Heptane. Good. 7 is heptane. Okay, so we can go this way. That would put these two at 3. That would put this one at 6. So let's try the other way. What if we do 1, 2, 3, 4, 5, 6, 7. So can you see we just switched the order we're numbering? So this way, if we go this way, with this being a 2, that will minimize the first carbon group. So the first priority is minimizing the first carbon group. So we would want this would be at the 3 position. Does that make sense? Okay, so we would say that would be at the 3 position. That's the best option. Okay, questions on that one? I'm just seeing like some blanks here. So are we okay? Just first box back. Okay, how about this one? What would we put that methyl group, the red methyl group? Okay, so you're saying we should go this way. 1, 2, 3, 4, 5, 6, 7, 8. So let's just check the other way. Let's see what the other way looks like. 1, 2, 3. Well, I have to put these funny. 4, 5, 6, 7, 8. So if we go from the left to the right, our first carbon is at 3, and there's 2 of them at 3. If we go from the bottom right to the left, then this methyl group is at 3, but there's only 1, so it's a tie. And if we go this way, we can get 2 to be minimized. So we're going to start from the left and go to the right, and this methyl group is going to be at 5. 1, 2, 3, 4, 5, 6, 7. Does that make sense? Because we can minimize 2 carbon groups here at the 3 position instead of just 1 here. So just make sure that you're checking both pathways. Look at both pathways. Okay, the next thing that we need to talk about is these common substituents, and I have those on your paper. So they also follow the same prefixes as our parent carbon chain. So the difference between the top left table and the bottom left table is that the top left is the parent chain, and this table is talking about the substituents, the branches. This is what we call the branches. So if we have a CH3 group somewhere in our long carbon chain, that's called a methyl group. If we have 2 carbons and then enough hydrogens to fill that, that's called an ethyl group. We also could have propyl, butyl, pentyl, hexyl, and it goes in the order of prefix. So if we have 1, that's methyl, 2 is ethyl, 3 is propyl. So you can come up with a mnemonic device to help you remember this. These ones are hard for me to remember. These were hard for me to remember. So when I was learning this, someone said monkeys eat peeled bananas, and that helps me remember these first 4. And then pentyl, that kind of makes sense because it's like pent is 5, hex is 6. So the ones after 5 I was able to remember, okay, but these ones were harder for me. So that's the mnemonic device the teacher told me was monkeys eat peeled bananas. You can think of another mnemonic device if you want to come up with something that helps you remember those. Okay, and then these 2 tables are from Alex. Oh, we haven't talked about the very bottom one. But this one, this first shaded table is from Alex, and these are the ones that mostly Alex will use. So methyl, ethyl, propyl. And then we can also have this funny group called an isopropyl group. And so the only way that a methyl group can be stuck on a branch is just through that 1 carbon. There's only one way for an ethyl group to stick on a carbon, like a carbon chain. But once we start getting to propyl, we could branch from the end, so that's just a propyl group, or we could branch from the middle of the carbon. So that would be called isopropyl. So do you see that, the difference? Okay. So when we start naming these, when you have to recognize these, we are going to use the common names, propyl or isopropyl. So watch out for that. Okay, so this is another Alex topic that we're going to practice. So looking at this, figure out which substituents we have at what location.
There'd be like 5 methyls.
Oh, okay. So you're saying all of these would be methyl groups.
Yeah.
That's kind of true, yes. But what we're going to do is we're going to look at the longest carbon chain, and then the other groups will be. That's a good point. There are 5 ends, so there would be 5 CH3s. So Trinity, you say that there's an isopropyl, so that's true. This is isopropyl. Okay, and then what position would that be? So let's count from this way. 1, 2, 3, 4, 5, 6, 7, 8. So this would be, what's our parent carbon for 8? Octane, good. So the parent would be octane. I think that's isoprene. And so then the isopropyl, we could also count this way. We could try that. 1, 2, 3, 4, 5, 6, 7, 8. But that would put our first group at 4 instead of 2. So we're going to go from the left to the right here. 1, 2. So we have an isopropyl group at position 5. 1, 2, 3, 4, 5. And then what would this group be called? This is our methyl group. Good. This one's methyl at position 2. Okay. So that's how we're gonna. So today is like figuring out how to name. Next time we'll start putting this together in and naming this systematically. So today we're just like building the skills we need to name. Okay, there's also one more substituent that comes up in Alex, and that is the chloro substituent. So if chlorine is attached somewhere on your alkane, that's called chloro. So here on the left, what substituents do we have? Good, we have a methyl group. So this would be our methyl. Oh, actually, you could pick any of them, it's the same. If we pick this one, it would be the same. I'm picking this one. Methyl at position 2, and we have a chloro group. A chloro group at position 2. And this parent would be 1, 2, 3. What's our parent chain for 3? Yep, propyl. Propane. Propane would be our parent chain. Okay, how about this one? What substituents do we have and what position are they? Yeah.
Oh, sorry.
Oh.
Left one. So
Yep.
do both of them get minimized since they're on the second carbon together?
Yeah.
Okay.
Yep. Yep. There's not another way. If we named it this way, 1, 2, 3, that would be the same. Or we could do 1, 2, 3. They're both always going to be at the 2 positions. There's not another way to count that one. How about this one? What groups do we have? Sorry? This one doesn't have methyls. All the methyls will be in the chain. So the only one is chloro. Oh, and then what position will it be at? Yeah. So chloro at 2. And then what is the parent chain here? Pentane. Okay, very good. So that is our last slide for today. So the rest of the time, you should either work on lab 5. Make sure you get that done turned in. You should work on chapter 12, Alex. We have the signature assignment you could work on. You could get ready for the lab, the last lab, lab 34. Bring the 2 labs. Or get study for the final. Lots to do.